Hi there and welcome to the channel. My name is Ferguson Mangoma. The channel is Cambridge Advanced Level Mathematics. In this video, we want to handle a very simple and straightforward example on integration by parts. Of course, we do have a video in the past where we handled integration by parts, but I realized the example there was a little bit too complicated. So today I thought I could simplify things a little bit. So the question we have here is integrate x sine of x with respect to x. The formula for integration by parts is what you can see here in green. I hope it's clear because my green is not always very clear, but I'll repeat the formula somewhere down here so that you can see it a little more clearly. So it says here integration u dv dx, and that's what you want to integrate, will be equal to u multiplied by v minus the integral of v du dx. Now, notice here that on this part here, let me circle it in red. On this part here, it is being expressed as u dv dx. Over here, we have v du dx. You start off with, this is a product of two functions. The function here, which is x, and the other function here, which is sine of x. So you have to make one of them u and one of them dv dx here. So that when you are over here, you now have to integrate v du dx. Let me show you what that means with reference to our problem there. So let's write it again here. It's x sine of x dx. Right. We have a choice. You can choose what you want to be u, you can choose what you want to be dv. But I will show you the pitfalls that arise, that you will meet if you choose your v or du wrongly. First of all, let u equal to x. Once we have made u equal to x, it now means dv dx will be sine of x. So dv dx is equal to sine of x. Now we have u, so we must find du dx. So our du dx will be equal to, you differentiate this, you get a 1. Now we want a v, because dv dx is equal to sine of x. So what is v? V is equal to, we integrate sine of x, we get a minus cosine of x. Let's look very carefully at what we have done here. We have said here is our product as the integrand. One of the products, x maybe, we can call it u. Then the other one becomes dv dx. When we have done that, we must find du dx, which in this case is 1. And we must also find v, because here it is given as a derivative. So we now want the original v, which is minus cosine of x. Now, when we have done this now, we can apply this formula. So the formula says u dv dx is equal to that. So what is uv? Remember, we said v is this. And u, we said it's that. So the start will be, this is equal to minus x cosine of x. Right? Then we come here, we subtract minus the integral now of, what did we call v? We called v minus cos of x. No, we called dv dx sine of x. So v is equal to minus cos of x. So we put here in brackets minus cos of x. What is it multiplied by? It's multiplied by du dx. What is du dx? It's 1. Now this with respect to x. Let me go through the process again. X, we said, is equal to u. dv dx is sine of x. U is equal to x. Differentiate u with respect to x, you get your 1. dv dx is equal to sine of x, so therefore integrate v this and you get your cosine of x. These are the terms here. Minus cos of x multiplied by x. That's what I have here. Then you integrate v du dx. Well, v is equal to this. That's what I have in the brackets. Du dx, we found it's equal to 1. So this simplifies to minus x cos of x. This minus and that plus minus becomes a plus, so it becomes the integral of cos of x times 1, of course, is just cos of x dx. And this simplifies to minus x cos of x. What's the integral of that? That gives you a plus sine of x plus, of course, a constant. Okay? That's the integral of this using integration by parts. The first thing that you must do, you look at the product of these two functions. Which one am I going to call u? Which one will I call dv dx? Then you apply your formula. It's now going to be uv. When you have done this process here, once you choose your u, you must differentiate that with respect to x. And in this case, we got this one. Once you have chosen your dv dx, you need to integrate it to get your u, which in our case, we got this one. So then you plug all this into the formula and you end up with this. And from there, we get to this point here. Now, I just want to illustrate to you what happens if you choose wrongly your du dx. So your u and dv dx. Let me just clear the board here. Sometimes you may be lucky. It may still give you a nice and quick result. In some cases, you end up in a ditch. I hope it's not going to be the case this time with us. So here it is now. Here is our integrand, x multiplied by sine of x. Let's say, let u equal to sine of x and dv dx equal to x itself. So look what I've done here. I've made this one my u and my dv dx is equal to x. Let me differentiate this with respect to x. Du dx is equal to, of course, cosine of x. I will integrate that now. V is equal to half x squared. I'm sure you are beginning to smell trouble here. Now, we plug everything into the formula. Here, what is my uv? It's half x squared multiplied by my u, which is sine of x, minus the integral of, where is it now? V, which is half x squared multiplied by what? Du dx, which is cosine of x dx. Okay, so it becomes half x squared sine of x minus a half integral of x squared cos of x dx. As you can see, what we have now under the integral sign is actually worse than what we had originally. So you have to choose your u carefully and your dv dx carefully. What it means now, you might have now to go through integration by parts again. So my point here is, when you choose your v and your u, your dv dx, you have to choose them extremely carefully. Till we see you in the next video, please take care.